4.4 is all about counting and doing permutations and combinations of different items. So we are going to look at the fundamental counting rule, which we talked about yesterday. So if we want to know how many events there are, then we could use the counting rule by multiplying how many outcomes from each one of the events. So multiply the number of outcomes for each event. So an example is toss a coin 3 times. So how many outcomes for the first event? There's 2 outcomes. What about for the second? And what about for the third time? 2 times 2 is 4. 4 times 2 is 8. So there's 8 total outcomes that can happen whenever you toss a coin 3 times. So we are going to talk about, trying to think of how I would say this. We have heads, 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 tails, heads, tails, tails, heads, heads. Heads, tails, 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 heads, heads, tails, heads, tails, heads, and heads, tails, tails. Nope, I've already done that. What is it? Tails. What is it?
Tails, tails, heads.
Tails, tails, heads. There we go. Okay, so whenever we talk about permutations and combinations, we are going to talk about the different outcomes if the order matters. So if I say you have a head in the middle and 2 tails on the outside. Or the other thing would be if we just have 2 tails. So if I say I just want 2 tails, what's probably getting 2 tails? The order doesn't matter, right? I could figure out, I could do this one or I could do this one. But if I say I want heads first and then 2 tails, order matters. So that's what we'll talk about today, how they differ and how you find each one. So example 1, to win a given lottery, you must choose 4 digits between 0 and 9 and repetitions are allowed. How many different lottery numbers are possible? So we are doing 4 digits between 0 and 9. So let's draw what those 4 digits could be. I'm just going to do 4 blanks. So in order to find out how many possible outcomes there are, we need to know how many possible outcomes for the first number. If the outcomes are between 0 and 9, how many outcomes is that?
10.
Yeah, 10. And it says repetitions are allowed. So how many for the second one? 10 also. Third and fourth. So in order to find out total outcomes, we would multiply that. So that's 10 to the 4th, which equals 10,000. 10,000 total outcomes. So think about playing the lottery and winning. There's 10,000 outcomes. But does order matter in that? No. You can get your numbers in any order. You can have repeats also. Let's look at example 2. Assume a criminal is found using your social security number and claims all the digits were randomly generated. What's the probability of getting your social security number when randomly generating those 9 digits. So the first 3 digits, and then it has 2 digits, then it has 4 at the end, right? Do y'all know y'all's social security number? Don't give it to me. But you should have it memorized. So how many outcomes are there for each one of these digits? 10. Can repetitions be allowed? Yeah. To find out the total outcomes, you'd multiply those, and that would be 10 to the 9th power. And so it says, what's the probability? What do y'all think the probability would be then? Probability of my social security number would be 1 out of that 10 to the 9th power. Because order matters. Example 3, you are in charge of planning an evacuation plan out of your office building. If there are 2 ways to exit your office on the 2nd floor and 5 ways to exit the building from the 1st floor, how many different evacuation routes are there? So this is just multiply the outcomes of each event. So how many outcomes from exiting the 2nd floor? 2. And then how many from exiting the building from the 1st floor? So it's just 2 times 5. So that means there's 10 ways. And during an earlier section, we talked about that tree diagram. So you could either go left or right, and then you could go down path 1, 2, 3, 4, or 5, right? 1, 2, 3, 4, 5. And then remember, we were like, that's a lot of work to draw those tree diagrams, so let's just multiply the outcomes, and we get the same thing. Factorial rule. So the factorial rule is the number of different arrangements of n different items when all items are selected. So number of different arrangements. Okay, so factorial denotes the product of decreasing positive whole numbers. So 4 factorial would be 4 times 3 times 2 times 1. So let's say you have 4 people that you're choosing for something, okay? So the first time you choose, you have 4 people to choose from, right? Then the second time, you only have 3 to choose from. Then you only have 2 to choose from. Then you only have 1 to choose from. So this is how many outcomes there would be of the different arrangements of that. So 4 times 3 is 12. 12 times 2 is 24. Times 1 is 24. So 24 total outcomes or different arrangements of selecting your team, I guess. So let's say we're doing 3 factorial. So 3 factorial would just be 3 times 2 times 1. So how many different arrangements if you have 3 items? So let's say the items are A, B, and C. So the arrangements would be A, B, C, B, C, A, C, A, B, A, C, B, BAC, and CBA. So those are the different arrangements that you can have with 3 different items. So order matters in this case. So there are 6. So 0 factorial equals 1. Example 1, you're planning a trip to Disney and you want to get through the following 5 rides on the first day. Space Mountain, Tower of Terror, Rock and Roll, Roller Coaster, Mission Space, and Dinosaur. How many different routes are possible? So you could do this first, this second, this third, this fourth, this fifth. So think about listing all of those out. There's a shortcut, and that's that factorial. Okay, there are 5 different rides. So we are going to do 5 factorial. Because the first one that you pick, there are 5 options. And now you only have 4 options. Now you only have 3, and then 2, and then 1. So this is 5 times 4 times 3 times 2 times 1. You can do this with the calculator, or you can just multiply. So 5 times 4, 20. 20 times 3, 60. 60 times 2, 120. 120 different routes to get all those 5 rides in the schedule. Have y'all ever seen, they used to have it on Sonic drinks. They had a little sticker that said how many different combinations of a drink. Do you remember that? Okay, I guess I don't have that anymore. But they used to, and it was like a crazy number. And the way they figured it out was by doing different combinations of the drinks. Factorials. Example 2, you're in charge of organizing science projects for this week's science fair. If there are 12 different projects, in how many ways could the projects be organized? So you're wanting to know how many different ways? You just do 12 factorial. Do y'all want to keep on doing 12 times and so on? Or do y'all want to know the shortcut for the calculator? Times 1. So it's down here. You type the number in first. So I'm going to put in 12. And then hit math. And then over to probability. And then your factorial.
The lady left my notes. What's the note for?
Whoa.
Okay. Yep.
He's a mess. All right, so we did that 12 factorial, right? So,
Wait.
479,001,600, right? Is that how you said that? Okay. You deliver newspapers as your part-time job. If you have 8 houses to deliver the paper to before school, how many different routes are possible? So you would do it 8 factorial. Go ahead and put that in the calculator. All right, permutations rule. So permutation is when items are all different and you're finding the different sequences. Different sequences. And since the items are all different, the order matters. So N is going to be the different items available when we select R of the N items without replacement. So our formula is N factorial over N minus R factorial. Permutations, arrangements, or sequences are all considered rearrangements of the same items to be different. So again, order matters. So A, B, C is not the same as A, C, B. That's what that's saying. If it's rearranged, they're not the same. They're different. So it's kind of like ranking things. So A is number 1, B is 2, C is 3. So that is different from A being first, C being second, and B being third. So we must conduct surveys in state capitals, but only have time to visit 4 state capitals. How many possible routes are there? So our N is going to be how many states there are. How many states are there? 50. And how many are we going to choose? 4. We only have time for 4. So we want to find out how many different routes are available. And we can choose any of the 50, but we're going to pick 4 of them. So we are going to use that formula, N factorial, R minus N factorial. So that'd be 50 factorial over 50 minus 4 factorial, which is 50 factorial over, is that 46 factorial? Okay, I want to show you how this simplifies though. Before you put in the calculator, or some of you probably already did, that's okay. I want to show you how this simplifies real quick. Because sometimes you'll be asked, what is the same as this? So we could expand this times 48, 47, and then 46 factorial over 46 factorial. So see how it went down? This means it's going down 2, but I'm stopping there. Because what happens whenever you have something over itself? Simplifies to equal 1. So all we're left with is 50 times 49 times 48 times 47, which that should be the same as you putting it in 50 factorial over 46 factorial. So I'm going to show you. So 5,527,200. But if I do 50 times 49 times 48 times 47, oh, I put minus, whoops. 50 times 49, 48, 47, I get the same thing. So I just wanted you to see how factorials can simplify, and you can make this simpler to put in the calculator, especially if you don't have that factorial. Okay, example 2. We must hand out fundraiser information to the 10 senior homerooms, but only 4 homeroom representatives available today. How many possible routes are available? So we have our total amount is 10, but we're only choosing 4. So 10 factorial over 10 minus 4 factorial. So 10 factorial over 6 factorial. Or you can subtract these and do 10 times 9 times 8 times 7. And that'll equal the same thing, which is 5,040. We can do this in the calculator too. So if we go back to math and we go over to probability, we have N, P, R. So it's like this. N is your total. R is how many you're choosing. P stands for permutation. Order matters. So if we wanted to do this one over here, we could put this one in. So let's go ahead and try it. So go ahead and select the number 2, NPR for permutation. And so the N value is 50 and the R value is 4. So you put them in those spots. So that was this one. Okay, and then we can do the other one. And that was, there were 10 where we choose 4. Pretty cool. Okay, so that is your calculator. Okay, sometimes we have permutations where you have identical items. So an example would be like, how many ways can the letters Mississippi be arranged? So we have to use a different formula because we have repeats here. They're not all unique. Like the last one, they were unique. These are repeats. So some items are identical to others. So we have N items available. Some items are identical. N would be all items. And we consider rearrangements of distinct items to be different sequences. So our formula is N factorial over N1 factorial, N2 factorial, N3 factorial, ... Nk factorial. So these are subscripts. So our subscripts are talking about, so like N1, N2, N3, and Nk. Those are your repeated items. And how many times it's been repeated. So our example with Mississippi, how many total letters do we have? 11? Yeah, there's 11. And then we would look and see what our N1, N2, N3, and 4 are, which actually there's only 3. Which ones are repeated? I is a repeat. And it's repeated 4 times. So 4 is going to be considered our N1. So then the next repeat is the S's. S is repeated 4 times. So that's going to be considered our N2. And then P is repeated 2 times. So that's going to be our N3. So we are going to plug this in the formula. So N factorial will be 11 factorial over N1 is 4 factorial because I was repeated 4 times. S is repeated 4 times, so that's 4 factorial. And P is repeated 2 times, so that's 2 factorial. No shortcut here. We're just going to have to put it in our calculator just like that. So go ahead and do that. This tells you how many different combinations or arrangements there are. All right, did y'all get the same thing as me? Were y'all able to put it in? 34,650. Different combinations for the word Mississippi. Okay, go ahead and do the second one on your own. Figure out what your N is. So our repeats are T, R, and O. Y'all agree? Were there any other repeats? T, R, O. Nope, nothing else repeated? Okay, so that makes it 12 factorial over 2 factorial times 2 factorial times 2 factorial. Is that a big number? What is it?
59,875,200.
Okay. Okay, when doing different orderings of the same items are counted separately, we have a permutation problem. When different orderings of the same items are not counted separately, we have a combination problem. So these are often confused. So permutation, order matters. And the way the book helps us remember, they wrote permutations, positions. Permutations, position. So that's kind of like your rankings. First position, second position, third position. But combinations are not like that. That's order does not matter. So we call that combinations committee. So if you're part of a committee, you're part of a group that the order doesn't matter. There's no ranking. So combinations committee, order doesn't matter. Permutations position, the position matters. Okay, so let's go over the combinations rule. We select R of n different items without replacement. We consider arrangements of the same items to be the same. So I could say ABC is equal to CBA. Those are the same. Because it's just saying a committee that consists of A, B, and C. Doesn't matter the order. So we have a formula for that. It's NCR. But our formula is n factorial over n minus r factorial times r factorial. So in the lottery, winning the jackpot requires that you select 6 different numbers, 1 through 49, and the same 6 different numbers must be drawn in the lottery. If the winning numbers can be drawn in any order, find the probability of winning the jackpot when one ticket is purchased. So a key word here is any order. That tells you it's a combination. So we use the formula where n from 1 to 49. N would be 49. And R is how many items we're choosing. And we are choosing 6. So now we plug it into the formula. So 49 factorial over 49 minus 6 factorial times 6 factorial. So it's a pretty big number. Natalie, what'd you get? Mm-hmm. Yeah. And we want to know the probability, right? So P of win is 1 in that 13,983,000. Whoops, 816. Didn't have enough room there. Example 2 is very similar. We're going to skip that out of time. But there is a formula, a button in the calculator that we can do, NCR. So N is how many you have, and R is how many you're selecting. C stands for combination. Okay, so let's look at permutation versus combination. When testing a new drug on humans, phase 1 of a clinical test is conducted with a relatively small number of healthy volunteers. Let's assume we want to treat 8 healthy humans with a new drug, and we have 10 suitable volunteers. If the subjects are selected and treated in sequence so that the trial is discontinued if anyone presents an adverse reaction, how many different sequential arrangements are possible if 8 people are selected from the 10 that are available? So we have N total, so N would be 10 to choose from, but only 8 are picked. And so the important word here, key phrase, is in sequence. So if it's in sequence, order matters. This is a permutation problem. Because they will discontinue if anyone gets adverse reaction. So the outcomes, we can do 10P8 in the calculator, or we can use that formula that we learned about. $1,814,400. Okay, the next one. If 8 subjects are selected from the 10 that are available and 8 subjects are all treated at the same time, how many different groups are possible? So they're all treated at the same time. There's no order. There's no ranking. They're just treated as a group. This would be a combination. So it's in CR. So 10, choose 8. So there's only 45 different groupings. So see the difference in how whenever order matters, it makes there be so many more different sequences compared to just a combination of group. All right, and that is all we are going to go over. So make sure you're keeping up with your work on My Math Lab.